Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at hexadecimal numbering systems. We'll be discussing hexadecimal and IPv6 addresses. We're going to do decimal to hexadecimal conversions, and then we'll take it back the other way with hexadecimal to decimal conversions. This episode is part of my series on Introduction to Networks. I'm Kevin, here at KevTechify. Let's get this adventure started. We've just covered how to convert decimal to binary and binary to decimal. Down here, you can see I do have a chart here that maps the first value of the decimal system is 0, which is equal to 0000 in binary. The second value is 1, which in binary is 0001. This is where it starts to get a little bit more tricky. Remember, binary only has two values. It has a 0 or 1. You can't have the number 2. That gives us the decimal number 2. The third value is equal to 0010. If we think about it, the first column here on the right, that has a positional value of 1. The second column from the right has a positional value of 2. 0 times 1 is 0. 1 times 2 is 2. That was how we converted into decimal. That's what we're at. Over here, 3 is equal to 0011. If we look, once again, positional value of the right column is 1. That gives us 1 times 1. Positional value of the second column is 2. 1 times 2. 1 plus 2 gives us 3. There's certain numbers that always seem to stick out. 4 in decimal comes out to equal 100 in binary. Once again, thinking of our positional values, we have a 1, a 2, and a 4. 0 times 1 is 0, 0 times 2 is 2, 1 times 4 is 4. That's an easy one to help you identify that you're doing this right. And a lot of times, if I had to take a test or something like this, I would write down a table like this. Pretty easy to do, pretty easy to understand once you see it. And as you follow down through here, you get all the way down to the 16th value. Once again, remember we did start at 0, so number 15 is the 16th value. The 16th value here is equal to all ones. 1, 1, 1, 1, 4 ones. There. Now, to compare hexadecimal, hexadecimal is basically 4 bits. 4 ones or zeros. Doesn't that look a lot like what we have in the binary column here? If we bring it up here, the hexadecimal values is that. And remember, hexadecimal means you have 16 possible values. You have 0 through 9. That only gives us 10 values. We need 6 more. What we do is we take the alphabet and we take the first 6 letters of the alphabet. A, B, C, D, E, and F. We add those on. Now, those are numbers just like if we would count them. And then the binary, as we go through here, for the first 9, match up just like the decimal counterparts, right? There. But as soon as we get to 10 here, we start over here because we only have the values 0 through 9. And so we start over, increment the next column. That gives us 10. But in the hexadecimal system, we're still on our first time through the numbers. So decimal 10 is equal to hexadecimal A. Decimal 11 is equal to hexadecimal B. All the way down to decimal 15, which is all ones in the binary, that is equal to F. That's the 16th value as we work through the system. The 17th value, we start over again and we increment the column to the left by 1. That's where 10 comes in. The 17th value in the hexadecimal system. The big question is, how do we convert from or to hexadecimal? The key, the big secret here is to always go to binary. That helps so much when you convert from decimal to binary and then to hexadecimal. Or you go the other way. If you're going from hexadecimal to decimal, always convert into binary and then take that step. That helps you get there. Why? Because converting from hexadecimal to binary, you look at the 4 values here, the 4 bits, that gives you 1 hexadecimal value. So 1 hexadecimal value equals 4 binary bits. That's easy to calculate out. You just grab the 4 bits and you look, is that the first value here with binary, or does that come down here to like the 8th value? Once again, remember, values always start with 0. So that's easy, that's 7. And then you can easily convert this into a decimal number. Always go to binary when you're going from decimal to hexadecimal or hexadecimal to binary. Why do we need to know hexadecimal numbers, and where are we going to see? Hexadecimal numbers are actually used in 2 locations you're going to be familiar with. First area is a MAC address. A MAC address is 40 bits long, but we take every 4 bits and we change that into a hexadecimal number. That gives us 12 hexadecimal numbers to represent those 48 bits of the MAC address. The second place you're going to see it is an IP version 6. IP version 6 addresses are 128 bits long. That's 4 times longer than the IP version 4 32-bit address. IP version 6, 128 bits long. Once again, we take every 4 bits, convert that, and then have that be a hexadecimal number. By the time we get done converting all those 128 bits into 4-bit hexadecimal numbers, we get a series of 32 hexadecimal numbers. Those 32 hexadecimal numbers are a lot easier to remember, to write down, to enter into your computer than those 128 bits, ones and zeros, that string of 1 and zeros is. That's why we like to use hexadecimal numbers, because it helps simplify for us humans long strings like the 128 bits. It was my pleasure to provide you with this wonderful episode on hexadecimal numbering systems. If you like this episode and you got value out of it, and depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com, and you can get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks. In the bottom right is one of my favorite videos that I picked just for you. Thank you so much for watching this episode of my series on Introduction to Networks. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.